Good morning, Year 11, and welcome to our lesson for the 24th of the 3rd, which is session 4. I hope that you've completed these do now questions and submitted them at the start of the lesson, because I do need to mark the roll like I wrote on the OneNote, and I need to also mark the roll at the end. So at the end of the session, please do not forget to submit all the work that you've completed. Okay, take a photo of it and submit the work that you've completed so that I can check it and mark it. So I've asked you to look at two things in this do now: the surface area of a sphere and hemisphere, and also the volume. And we should know from our formula sheet that the surface area of a whole sphere is 4 pi r squared. Okay, we should write down the formulas and then we would go through. And in the first one, it's 4 times pi. I'll put a times in there if you want, because that's probably what you did on your calculator. 4 times pi times 5 squared. And then using our calculator, 4 times pi times 5 squared is 314.16 to 2 decimal places. 314.16, and that would be a square unit because it's an area and it's square centimeters. The hemisphere, well, we've got two parts for this one. It has the curved part around the outside, which is half of our sphere. Okay, so we've got our 2 pi r squared for that curved part. Okay, that's half of 4 pi r squared. But we also have this green top part of the hemisphere, okay, which is a circle, so that part there is pi r squared. So in total, we end up with 3 pi r squareds. Okay, so what we would calculate is 3 times pi times r, which is 6 squared, not 12. Okay, the radius is only 6. Okay, so in this case here, we should have got 3 times pi r squared, 3 times pi times 6 squared, which is 339.29, 339.29, and that's square meters. Okay, I also asked you to work out the volumes, which is 4/3 of pi r cubed. So our volume for the first one is 4/3 times pi times 5 cubed, and we would have to make sure that we show our working. Okay, we always show our working, what formula you use, what you substitute into it, and then the answer. And I'll just write that in: 4/3 times pi times 5 cubed, 523.60. We would write round to the 9, we'd round up to a 10, and then that would become a 6. So 523.60, and that is in cubic units because it's a volume. So little centicubes. That's how much space or how much volume it takes up. Okay, the second one, we just have to make sure because it's a volume, we are not adding our pi r squared or anything to this. There's no plussing on it. It's just half of a ball. We just have half of 4/3 of pi r cubed. Okay, so that, because we have half of 4/3, we would have 2/3 of pi r cubed. So we should have got 2/3 times pi times 6 cubed. Now that gives us 2/3 times pi times 6 cubed gives us 452.39, and that's in the cubic meters. 452.39 cubic meters. Okay, so today we are looking at the capacity conversions and how to calculate those with those. Okay, so please put the heading capacity. Your date should already be above our do now. And what we are looking at here is how much liquid is being held in a shape instead of how much, say, space is being used. And I talked about it in class already. However, the conversions that we have is that if you are dealing with units of meters, which would mean that you would end up with a volume of cubic meters, we have a direct conversion of having a cubic meter of, say, a cubic meter of volume, 1 meter by 1 meter by 1 meter, that holds a kiloliter of water, 1 kiloliter of water. Okay? Now, kiloliters is used quite often. So, for example, water bills are charged in how many kiloliters you use. It's currently about $2.20 per kiloliter for Sydney water. Okay? The other direct conversion that we know is that cubic centimeters is the same size as a milliliter. And I talked about this as well. That's why we sometimes see motorbikes having cc for cubic centimeter, and we might see a bike that is 250 cc, means that its pistons that go up and down, maybe it's just say it was a single cylinder piston, it would hold 250 mils, or say, of liquid if it actually did, but it doesn't do that in an engine because the piston's going up and down, compressing and then expanding as the explosion happens. Okay, but we have 650. Let's have a look here. So now we've got cubic meters, cubic centimeters. Just checking the volume works. It does. Now, what we need to make sure then is most questions ask you to put them in liters. Okay? And we should know with our different conversions, kilo, and then basic, our unit, and then milli is the same as kilometer, kilometer, to meter, to millimeter. They're the same kind of conversions, or kilogram, gram, milligram. Okay, the kilo is just a prefix, so in front of it, but that means we would times this by 1,000 to get liters. 1,000 liters it's saying. And the other way, I mean, you could keep going and also times this one by 1,000 if you want, but if we're going up to a larger unit, we always divide by 1,000. Okay, we divide by 1,000 there. So if we look at some examples of this, so just say I want to run a bath instead of a shower, and my bath is a rectangular prism. I know it's not going to be that comfortable if it was, okay, but I have a rectangular prism bath. I measure my width of that bath and say it's 60 centimeters wide, or 0.6 meters wide. I then have a height. Maybe that height, I'll fill the water, not the entire height of the bath, but I might fill that water, say, 40 centimeters high, 0.4 meters high. And my bath is long enough to lay down in. It's probably 1.7 meters long, so that I could, it's a bit shorter than me, but so that we can lay down in that bath. So I'm just estimating what the bath is at home, but therefore I would work out what the volume of that bath is. It's either length times breadth times height, or we could work out, say, the area of our cross section, 0.6 by 0.4, and then times it by the height, using V equals AH on our formula sheet. Okay, so I'll I'll use that because it's on our formula sheet, but it's 0.6 times 0.4 is our area, and then we're going to times it by 1.7. Okay, so that will get us our volume of our bath, which is in cubic meters. So 0.408, 0.408 cubic meters. Now, if we wanted to work out the capacity, then we would say capacity is a direct conversion of this to 0.408 per kiloliters instead. Okay, so Sydney Water would charge me about $2.20 times by that answer, so about 89 cents to fill up that bath. That's just for the water. Of course, it costs money to heat the water as well. So it costs you over $1 to run that bath. If I wanted to put that answer in litres, I would times this by 1,000, and therefore I would get 4080 litres. You can put that on your calculator. Well, I got that wrong, because it should only jump through, the decimal point should jump 3 places when we're times by 1,000. So times by 10, times by 100, times by 1,000. So it's actually 408 litres. Okay, if we looked at an example to check the size of a can, for example, just say I'm using a cylinder and I have the radius, I would say, just say the diameter, what kind of fits in our hand, about 10 centimeters, just say, and our can is, oh, actually it's not 10 centimeters, it's a big can. I think the can's maybe about 6 centimeters diameter, just looking at the ruler now. So that's 6 centimeter diameter, and the height of the can may be about 11 centimeters high. Okay, so if we follow our same process, we would work out for EG2, the area of the cross-section is pi times 3 squared. That's that area of cross-section, the circle that's all the way down. Pi times only 3 squared, which gets you pi times 3 squared. Okay, 28.27. And then I would work out the volume by multiplying that area, 28.27, by the height of 11. So 28.27 times by 11 would get me, times by 11 gets me 311.01 cubic centimeters. Now, that's a pretty good estimate, because looking back, a cubic centimeter is a mil, and that's approximated to be 3, so that's the same as 311 mil. So the capacity is equal to 311 milliliters. Or, well, it's approximately, I should put the dots above it, it's approximately, because I've rounded off quite a lot. Or I could say that's approximately 0.311 or 0.3 litres approximately. My last example today is to look at our rainwater and how much rainwater will land into a water tank. So suppose I look at Google Maps, and we could just estimate the size of an area. So I'm currently, as you know, in E Block, so here's Cumberland High School, and so here I am here. So just say I have an area and I have a land, and I might use the trapezoidal rule if I wanted to in a question to work this out, or I can measure the distance and say, just say it rains from there to there. It's 37 meters, this building, and then goes from 37 to 57. So 37 meters by 20 meters onto this building. Okay, so I get a building. I don't care about the height of the building for EG3. It doesn't matter because the water's not going by the height of that building, but I have a building that was 37 meters by 20 meters as an area that the water is going to land on. Oh, I wasn't in the right spot. There you go, I just did that. Doesn't matter about the height, but that means the area is going to be 37 by 20, which is 37 by 20 is 740 square meters of area. Now that's important because when we look at the rainfall and we see what actually happens, so we sometimes hear that it rains and it says it rained 20 millimeters if it's a rainy day, or it might say it rained 6 millimeters or 8 millimeters, or the really heavy days, you know, they can rain 100 millimeters, but that often, you know, hopefully that's over the whole day. If that comes down at once, we get flooding. But just say it rains 25 millimeters. So a very rainy day, we get 25 millimeters of rain going on this roof. Then what we can calculate is this prism of where that rain is all going to accumulate on the roof. You know, we get a prism like this, and all of that's going to be rain 25 millimeters high over the day. And all of that rain is going to go down a water tank, go down a drain and into, say, a water tank, or it's going to flow off. Now, just with these calculations, I've just done a prism on the roof, so the volume is going to be AH. However, that's 740 millimeters, square meters, has to be multiplied by the height in meters as well. Okay, so we just have to realize, I'll just put it here, that 25 millimeters, which is the same as 2.5 centimeters, which we then divide by 100, is the same as 0.025 meters. Okay, so we get 0.025 meters and I times it by 0.025 as a height. 18.5. So now I end up with 18.5 cubic meters of water that went onto this roof. 18.5 cubic meters. We could then see that that is the same in terms of capacity of 18.5 kiloliters, or 18,500 liters of water, which is quite a lot. When you look at Bunnings water tanks, they might be a 5,000 litre tank. You know, the big ones are 10,000 litre tanks. If we actually had an enormous tank, so for example, in our school, I think we've got a tank here. I'm not sure what it's used for, but I think it pumps for the water in the toilets. But you know, if I measure this, let me go measure the distance here. Measure, clear measurement, measure distance. So if I get my there you go, it's 8 meters diameter wide. 8 meters diameter. So if I get my 18.5 kiloliters of water and that all flows into the water tank, then what we get is, how high is that water tank going to be filled? How high is it going to be filled? So imagine you've got a cylinder, and we get with a 8-meter diameter or a 4-meter radius, and we want to work out how high this is going to fill with 18.5 kiloliters or 18.5 cubic meters. So what we get is volume is equal to AH, okay, or 18.5 is our volume. 18.5 is our volume, so 18.5 is equal to A, which is pi r squared, pi times 4 squared, times the height. There. Okay? And therefore, if we want to just work out the height, this is an equation. We could divide this side by pi r squared, pi times 4 squared, and we'll divide this side by pi times 4 squared as well. So we can actually work out how high this tank is actually going to fill by getting 18.5 and dividing that by brackets pi times 4 squared. Okay, so this is how many meters. There you go. That tank, the height of that massive tank just near the basketball courts is going to rise by 0.368 or 36.8 meters. Okay, with just 25 millimeters of rain on our roof. Okay, and that is a really big tank. I'll finish this here. What your work to do today is to look at exercise 6K. Exercise 6K in your books, and submit your work before you finish your maths work for the day. I need to mark the roll. I need to check to see your work. So if you have any questions, please ask me. I'm more than willing to help, and I look forward to seeing your work.